Okay. Hello again. Um, Number three, part three of N, of me doing this live streaming of writing some Ruby code. For those who are just joining us, I'm writing a WebAssembly interpreter in Ruby. I'm doing it to have fun, to demystify WebAssembly for myself and maybe for you, and to share how I do it, show my working, whatever process I have, show you that. I'm recapping this for myself, not for you. And the kind of principles I want to remind myself of as I do this is that it's more important to have fun than to produce something functional, more important to make something correct than something that's fast. It's better to be clear in my code than clever in my code. I'm going to try and do it in pure Ruby, and I'm going to try to not have any dependencies. So that's what I'm doing. I'm just going to pick up from where I got to last time, see how far we can get on this stream. But first, like I did last time, I'm going to just do a very brief retro on things that I thought about after, well, reflecting on what happened last time, trying to think about what, if anything, I want to change this time. Number one, for the first time I had a look at this stream on my TV, and I love complaining about text being tiny. Quite a lot of the text on this stream is tiny, so I'm going to make the text a bit bigger. I like to fantasize that somebody is reclining on their couch and watching me write some Ruby. Maybe that is not the case. But I would like for all of the text to be legible ideally. So I'm going to try and make sure that it's a little bit more legible, because it seemed the default font size, although it looks fine on my monitor that's right in front of my face, maybe not particularly legible on a television. Last time I tried to talk about what a bijection was, and I just fumbled it really badly. I gave one of those explanations that's like an explanation that only helps if you already know what the thing that's being explained is, which is to say, not helpful at all. So I just want to take a moment to correct the record and say that a bijection is a kind of function where every input produces a unique output, and every output is produced by some unique input. So as long as those conditions hold for a function, as long as for any input you can say uniquely, here's the output that you get, and also for any output you can say uniquely, here is the input that produced that output, then it's always possible to define an inverse of that function, kind of by the definition I just gave. If there's a function that maps inputs to outputs, then if every output comes from some unique input, you can just make a function that goes the other way. And this came up in the context of signed representations of numbers yesterday, and the word bijection appeared in the documentation. I sort of muttered something unhelpful when we read it, and so I just wanted I wanted a do-over of that so that I could actually try to, competently say what it was. So there we go, that's what bijection is. Also last time, I again sort of fumbled thinking about why I wasn't writing any unit tests. I mean, I certainly felt uncomfortable about the fact that I wasn't writing any. Like in the first stream, I wrote a lot of unit tests for the parser, but then last time I sort of, it never came up that I felt like I needed to do it, and that's very unusual for me. Like my default way of working is writing unit tests and then just like only occasionally running an acceptance test. So it felt a bit strange, and I didn't really know why. But it occurred to me in the meantime that the file that we are interpreting contains unit tests, like that that file that's got maybe I can show it if I can bring up a browser. That is not my web browser. Okay. Yeah, I'm just sort of improvising something here that I wasn't thinking I was going to do. So the file we're interpreting at the moment is, or that we were interpreting last time, was this int literals.wast. And essentially each of these is like a little unit test, which is obvious, like that's why we're doing this in the first place. Yeah. And so, yeah, it just didn't occur to me when I was talking about it yesterday that, like, I think this is the reason why I didn't feel like I needed to write unit tests, is because this file that we're interpreting is just a bunch of unit tests. It's just slightly unusual because we're building the interpreter that's sort of running these tests itself, rather than having sort of tests around the outside that we're writing. They're sort of inside the thing that we're interpreting, which is a bit odd. But, I felt a little bit better about that once I thought about it, and I was like, oh yeah, it's not like there aren't any unit tests. It's more that we're sort of in a slightly unique situation where the acceptance test actually consists of a big old chunk of unit tests. And so that normally that situation where you get a failure in the acceptance test and then you have to bounce down and write a unit test to sort of recreate that failure so that you can work on it and then go back up to the acceptance test, doesn't really make sense here, because the failure in the acceptance test, like, it's just the next unit test that's failing. Anyway, it's not interesting, but it's true. The next point was about writing a better parser, and actually there was a very good comment on YouTube from CVE, and they said, for the bit where you pattern match on i32.const or i64.const with a regular expression and then access match data, I wonder if you could change your parser to represent i32.const as an array of 32, integer symbol, const symbol or something, and do similar for i64.const. Doing that would mean the pattern matching becomes much simpler because you wouldn't need to chop up a string and access match context, and I think you could get rid of the nested case statement. And I think that is all true, and it made me think about something that I sort of more broadly that I wanted to mention briefly, which is that, at the moment, intentionally, the parser is extremely basic, and I think I talked about this a little bit in the first stream. It's not doing any real syntax analysis at all beyond just sort of finding parentheses and finding the boundaries of atoms. So it's barely doing any parsing really, and that, as a result, it's pushing a lot of work onto the interpreter that we're doing right now. The interpreter is now responsible for understanding a lot of the details of WebAssembly syntax, which I think is what CVE was referring to as, like, they were giving an example of one instance where we're sort of doing more work than seems strictly necessary in the interpreter. Like, couldn't the parser have done that? And that's all true. I think ideally what we eventually want is, instead of doing all of this work in the interpreter to deal with the sort of the contents of that raw S expression, I think it'd be nice to have a sort of staged computation where the sort of evaluation happens as a series of sort of a pipeline of discrete stages, and at the moment we've got that stage that turns a string into an S expression, or a string into a sort of structured data, and then there could be another stage that turns that S expression into a sort of a richer abstract syntax tree with richer nodes, typed nodes that have they know whether they're a keyword or a variable name or whatever. And then building that abstract syntax tree would be a sort of another stage of execution. And then the stage after that is interpreting that abstract syntax tree. And that means that the work sort of gets spread out across multiple stages and sort of compartmentalized. I mean, I don't know if it's worth having a parser that all it does is produce an S expression and then have another parser that consumes the S expression and builds an AST. Maybe you'd want to combine them into the same stage. But the reason I am separating them is because I've already got the first one. So I'm sort of hypothesizing another stage that comes after that, that sort of chews through that regular expression, the S expression, and it knows the significance of the various symbols that it finds, and it knows what the grammatical structure of a WebAssembly program is, and it can sort of build nice, rich representations that are sort of extremely easy for the interpreter to deal with, because all of the information it needs is just right there in the abstract syntax tree. So I'd really like to get there. However, I'm sort of resisting the temptation to do that right now. I think what I want to do is just power through making a prototype sort of by brute force, without getting sidetracked by, high-minded concepts like engineering or, getting something working well. And also it occurs to me that right now, I don't really know enough to know what, if I wanted to have such an abstract syntax tree that was designed to be nice and easy for the interpreter, I don't actually know what that would look like. So part of my goal here is to sort of, like I say, sort of grind through getting this interpreter implemented just on top of that really raw S expression. Probably end up putting a lot of logic into the interpreter that doesn't really belong in the interpreter, and then maybe afterwards, once I've got something basic working, maybe there's an interesting refactoring to do there to sort of, rather than speculating on what I think that sort of intermediate representation might look like, instead I can look at the code that I've actually got and say, like, well, it looks like I need these kinds of nodes, and these are the operations that they need to support and stuff like that. So sort of mainly laziness there, but I'm also trying to make an effort to sort of defer the thinking until I've got a bit more information. So that's the high-minded version of being lazy, I suppose. That's it. Let's have a look and see where I've got to. Where did we get to last time? Let's have a quick look. I think that I got to a point where I could run wasminer.rb and give it that wasm spec test core in literals.wast. Yeah. And that was all the output that we were expecting. I'm just going to pause and have a look at what I put in my... Okay, well, firstly, I'm going to embiggen this like I said I would. Hopefully this makes it a bit more legible, potentially at the cost of being able to see quite as much of it, but never mind. Oh, yeah, I thought about a few... I'll make the notes in browser text bigger. Yeah, I suppose there's no reason why this needs to be massively smaller than the text in the terminal, so hopefully that's a little bit more legible now. Okay, I don't necessarily want to do all of these things. Oh yeah, rename directories. I found myself tripping over a bit last time. Like, I keep forgetting what this wasm spec thing is called, and also I'm in a directory called wasm, but I've sort of renamed this. So what I'm going to do is rename wasm to wasminer, and then actually... Yeah, okay, I think this is what I want to do. I'm gonna sort of repurpose this wasm directory as sort of the overall project, which contains this interpreter that I'm currently writing, but also is going to contain that wasm spec. And I'm actually just going to call it spec because that's the name of the repo on GitHub, is github.com/webassembly/spec. So now I've got these sort of side by side, and now hopefully I can do wasminer spec test core in literals, which for some reason is easier for my brain to deal with. And now at least this is in a directory which has got the same name as the project and actually the GitHub repo that I made last time as well. So that feels a little bit nicer. Okay, done. That was easy. I don't necessarily want to work through all of these before I get stuck in. These are things that I thought I wanted to do. Do I want to do this run test with GitHub Actions? Actually, maybe that would be a nice kind of palette cleanser before I get stuck into get stuck into something new. Yeah, let's do that. It won't take. Well, I was going to say it won't take more than 5 minutes. It'll probably take more than 5 minutes because I'm going to talk about it while I do it, but it's not going to take very long. So let's just do that. And if I suppose if this is something that you are not familiar with, then maybe it'll be interesting to see how that works. So what I'm talking about here is using GitHub Actions to run, I guess, this. Oh, and I suppose also we could run sExpression parser test.rb. And I think that took... Oh, actually... So there's that. I mean, maybe that's it. Maybe that... You know, I was going to say, well, maybe we should also try and run... I think I took the code out to read from... Yeah, that's just the source of... Okay, all right. Well, in that case, it will just be running the sExpression parser.test.rb. So I've got a couple of things that I can run locally to check that everything's working okay. I can just configure this repo to run those tests when I push a commit, and that'll just run on, I guess, Microsoft's cloud infrastructure, and I'll get a sort of green dot next to my commit, and I can go and have a look at the test output and stuff. So I think it would be nice to do that. What's interesting is that this is really quite easy. I'm going to avoid digging into the documentation and stuff because I feel like this is a little bit off topic for the stream. It's just something I want to get done, and I thought I'd do it on stream. But I know for a fact that there's Ruby setup Ruby is one of the actions that I want to use. And an action is really just a GitHub repository that's got some code in it that you can execute on the GitHub Actions infrastructure. And I know that this is the one that I always use to install Ruby. So, okay, this has got a nice example. You can see it's, you configure GitHub Actions by just sticking a YAML file in your Git repo. In fact, this is very close to what I want to do, so I'm just gonna copy that. So we need to make a directory called GitHub. I think it's workflow. Is that the right name? It's workflows. And then we need to make a YAML file in that directory. I'll call it CI for continuous integration. So that's what I've copied from there. So let's change this, call it CI. This is fine. This says run it when a commit gets pushed, which is what I want. I'll leave pull request in here, even though, well, I'm not intending to open any pull requests, but who knows, maybe you will. So I'll leave that there. That just means run, well, it means something a little bit subtle actually. It means run this when there's a push to a pull request, but run it on the speculative merge commit that GitHub makes when you push to a pull request. So run the tests against what the final result of the merge will look like, which is subtly different from running the test on the actual contents of the commit that's been pushed. And so I think it's important to have both of those, and clearly Benoit or whoever made this thought that was important as well. We want one job called test. That's the ideal name for it. We want it to run on the latest version of Ubuntu. That's great. Uses actions checkout, so that's another GitHub repo. This just means it's going to check out the it's going to check out this Wasmina repo, which is what we want. And then this setup Ruby, where we copied this from, is going to say with a particular Ruby version, we don't need bundler cache because we're not installing any gems. And oh, okay. Yes, all right. I'm thinking about this now. Okay, so we don't want to run bundle exec rate. We want to run something else. It was this thing I just typed, right? Something like this. But the reason I paused there is that I realized that we need to have 2 repos checked out, actually, not just one. So we're going to run something like this. And whatever the other thing was, the expression parser test. Yeah. Let's run that first. So run the expression parser test, run the interpreter with that int literals. But of course this file is not going to exist because this repo hasn't been checked out. So we need to use this action twice. I think, I can't remember what the key is. Is it repository? Yeah, I think there might be a side-by-side example in this README. Check out multiple repos side by side. Yeah, this is exactly what I want. So this is saying, using the checkout action twice, check out this is not specifying a repository. So this is just saying, like, check out the current repository in this directory, and then check out a different repository in a different directory, which is exactly what I want. So I'm going to say, check out this one in a directory called wasmina. And for this one, I want to specify that it's actually going to be a different repository, which is webassembly./spec. And I will put that in a directory called spec. So this is, I didn't have to put the current repo in a subdirectory. It could just be like in the GitHub workflow root directory, or the GitHub workspace or whatever they call it. But I think it's nicer to, instead of sort of smashing one repo inside another, I think it's nicer to just have them side by side. So let's have those 2 directories side by side. We check this out into spec, and then this becomes like this. So those files live inside the wasmina directory, and then this one, I just don't need that. You know, this file is going to be inside the spec directory. So, oh, and this -i becomes put the wasmina directory on the load path. So I hope that this is going to work. Really, the only way to find out is to try it. Add GitHub actions workflow to run the tests. Now, I'm just going to eyeball this. I mean, I'll be annoyed if I push this and I've made some kind of syntax error. I'll be mildly annoyed because I won't be able to resist temptation to force push it, because I don't want to leave all broken junk in my commit history. And I don't think GitHub Actions, at least by default, doesn't run workflows that aren't on the default branch. So I sort of need to just push this up onto main. But let's just YOLO it and see what happens. Okay, so I would expect to see something happening here. Okay, add a GitHub Actions workflow. Here we go. It's running. Starting job. It's installing Ubuntu, checking out those repos. Something went wrong. Syntax error. Interesting. I did specify a Ruby version. So I don't know why it's complaining about. I mean, it looks. Oh, hold on. What's happened? So let's try doing it. Let's try doing exactly what that workflow said? It said, well, firstly this, which seems to work fine. And then this, which also worked fine. Why is this complaining about syntax error, unexpected comma? Is it because this is Ruby 3.1? Yes, thanks, Afuk. I was just like, hold on, this is this is a feature of Ruby 3.1. Oh, I've got the Ruby version wrong. So yeah, that was the... I knew there'd be some kind of deliberate error. Thanks, Afuk. You got my back. So yes, I had forgotten. Well, I just copied and pasted this from Benoit. You need to update your example YAML. Okay, let's just pretend that didn't happen, and no one will ever know. Okay, let's try again. All right, I'm hoping this is going to be over soon. Yes. Hi, Afuk. Nice to see you. Long time no see. Okay, so the checkouts have succeeded. GitHub's web UI hasn't succeeded, but the thing has gone green, so there we go. Wow. How do WebSockets even work? Okay, so I mean that's not that amazing, but it is working. I've got those tests running now. Let's just see it fail. So if I edit this and make it so that this add instead becomes subtract, then I would hope that this test would now fail. Yes. Okay. So if I push up this branch, because there's no point having tests that where there's no point having tests unless you've checked that they do actually, you know, if this dot doesn't go red, then this whole thing was a complete waste of time. Arguably this whole thing is a waste of time, but let's see what happens. Hey, it went red. Okay, again, GitHub's UI leaves something to be desired. But yeah, this is exactly what I wanted. And yeah, something I didn't explicitly mention here is that GitHub Actions uses the exit status of the shell command that you put in the run line there to sort of determine whether the tests have passed or failed. So this is just through a convention that travels all the way through every piece of this infrastructure. Me raising an exception inside the Ruby code is causing the exit code of the Ruby interpreter to be non-zero, and then GitHub Actions is picking that up, and that's making something go red on a web page. Isn't Unix wonderful? So that's cool. Okay. I'm happy with that. I do not need that branch no more. I just wanted to see it fail. Okay. So that wasn't, I know that wasn't really about WebAssembly, but it was on my list. So I'm done with that now. That was like a little palette cleanser. How many of these do I want to look at before I carry on? I'm going to ignore that. Oh yeah, it did actually quite bother me that this local variable, I called it signed, which was like, this is something that contains a Boolean that tells you whether there was a minus sign at the beginning of the number. And I think signed is a misleading name for it. What I meant was, is the number negated or is it negative? And so, just because there's no minus sign at the beginning of it, you don't know whether the person who wrote that number intended it to be a signed number. It might be a positive signed number, which I know is a little bit pedantic, but I am a pedant. So I'm just going to change that, assuming that we haven't broken anything. Core test. I mean, arguably, it would be useful for me to have a rake task or something that runs these tests rather than me having to laboriously type it out every time, but whatever. Okay, it's still working. So let's say rename signed local variable to negated. Pedantically, imagine misspelling pedantically, that would be awful. Pedantically, we don't know whether the literal is supposed to be a signed number or not, only whether it's a negative number. So let's be accurate about that in our naming. Not just about pedantry and accuracy, but also clarity. Like I said, I wanted to prioritize clarity over other things, and I think having things whose name is almost but not quite correct actually sort of works against clarity. So I've dealt with that. I'm not gonna. This is less important. I mentioned this last time that interpret was a bad name for that method, but I'm not going to waste your time on watching me do that. Maybe next time if it starts to really wind me up. This was something where I was sort of like, oh, there's something going on down here where really we've got some logic in here that's about converting a signed number to an unsigned number. It occurred to me that I actually don't need to do this. I don't need to set this flag and then strip the minus sign off the beginning, because string 2i can actually deal with that leading minus sign. So if I had a helper that I could just feed in a number, positive or negative, and it could just convert it to an unsigned number for me, that would be really nice. But that feels like a little bit of a distraction at the moment, so I'm not going to do that yet. Afuk is asking, could numbers be in exponential format? They certainly could, and in fact, well, actually, that's a really good question. I don't think that integers in WebAssembly can be. Bear in mind, these are just fixed width integers that I've implemented so far, so 32 and 64-bit integers. I think if we go to... the existence of int literals implies the existence of float literals. I think if we go to this is going to have exponent. Oh, yeah, I mean, this is a notational nightmare. It's got syntax for nans. Oh no, this has got C99 hex. I'll explain this when we come to it, but I can see that it's got C99 hex literals for floats. But yeah, long story short, oh, I see what you were worried about. Yeah, you were worried I might be removing a minus from the exponent. In this case, no, that is not a problem because, well, on the evidence presented to me by this acceptance test, which is all I'm paying attention to at the moment, you can't use exponential notations in integers, only in floats. And I'm going to get to floats hopefully quite soon, and I'll have to be much more careful about that then. But for now, I think it's okay. So yeah, I'm gonna put a pin in this one, but I might come back to that. I do like the idea of just letting Ruby interpret it as a negative number and then just be able to squirt that number through a helper function that can turn a negative integer into an unsigned integer, but I don't have that right now. Oh, hello and goodbye, Jean-Christophe. Thank you. I'm glad you love my book. Everyone else on the stream, buy my book. Oh yeah, Afuk mentions delete prefix. That would be a nicer way of doing this. Yeah, that's true. I'll tell you what, the reason why, yeah, this could be delete prefix, couldn't it? The reason why I used tr here, I didn't say this out loud, which I should have done because I definitely thought it in my brain, was that I thought I was also going to need to strip other characters from the string. Because I'd sort of spotted that there were these things down here. I was like, oh, I might need to strip those underscores from the string. So I was actually being a little bit premature in saying like, oh, if I use TR here, then if I need to remove those underscores and, you know, white space or anything else, I can just add those things in here. Now, as it's turned out, yeah, I actually didn't know off the top of my head. I know that Ruby supports this syntactically as in source code. I actually didn't know whether toInteger supported this, but it does, so I didn't need to do that. So you're quite right. This could be delete prefix. I'm gonna impale that on the same pin as am I just gonna, because if I do end up having this signed to unsigned helper, I'm gonna get rid of all of that rubbish. So I'm gonna leave. I know I just touched it by renaming this, but that really bothered me. These other things might just go away in the fullness of time. Oh yeah, this does bother me. I am going to fix this. I'm sorry. I know we're more than half an hour in and I haven't actually started on the integer instructions yet. But I wanted to make sure I'd done the cleanup. So I've got two regular expressions to match i32.blah and i64.blah, and in both of them I just typed a literal dot, which is not correct. That needs to be escaped. That annoyed me very much when I spotted that I'd done it, and so I wanted to make sure I remedied that. Still works. Escape dots in instruction regular expressions. I don't think there's no point. I was going to write a commit message that explained that, but I would just be expanding on what I'd said there. I think it's obvious. So I've done that. And yeah, I think this is the final thing I'll do now. I'll leave this. It bothered me that I was using regex last match last time. It occurred to me that the reason I was doing that was because I really wanted to use pattern matching with a regular expression, and currently the only way to get hold of the match object that's produced by that regular expression match is to use regex last match. But actually, particularly here, I'm not really getting very much value out of the pattern match. This could just as well be a normal conditional, and then if it was a normal conditional, I could call match and assign the result to, I could assign the match data to a local variable and not have to use a regular expression last match here. So this is unnecessary, given that the pattern match isn't really doing any heavy lifting here anyway. But I'll come back to that later. But the thing that did bother me was that it's important to me that these regular expressions are anchored, because that is what I meant. So what I meant is, if the instruction, that's not at all the key I meant to hold down. If at the start of the instruction we have i32 or i64 dot const, and then that's the end of the instruction, then that should match. I did not mean if this sequence of characters appears anywhere inside the instruction. So although that's not causing any problems right now, at the very least, I didn't say what I meant, and I have now said what I meant. So again, I think that helps with clarity, even though I realize regular expressions aren't super easy to read. I think someone who knows how to read them, I think realizing that this matches the entire instruction rather than some substring of it is actually important. Fox says, don't bits and operation become locals? What, if you have named captures? I mean, that would be amazing if they did. I mean, let's find out. I don't know. Anyway, let me do this. How did I describe them? Add star and end. I'll just say add anchors to instruction regular expressions. And I'll say it's important to be clear that we're matching the entire instruction here, not a substring. So I don't think you do get local variables that are named after the capture groups, but it would be absolutely brilliant if you did. So I'm gonna try and see what happens. Oh, fuck, if this works, it will totally blow my mind. Oh, it doesn't work. That's a shame. Oh well. No, I mean that would be great, wouldn't it? I was thinking about this a little bit and thinking that like this is an annoying limitation of pattern matching. Like it's good that you can use regular expressions in a pattern. That's great. But it's annoying that all you can do. So here I can assign the string that matched can be assigned to a local, but there isn't, as far as I know, any mechanism for assigning the match data somewhere, but it's really the match data that I want. I'm going to read what Ifuck's saying. When named capture groups are used with a literal regular expression on the left-hand side of an expression and the equals tilde operator, the captured text is also assigned to local variables with corresponding names. That's interesting. I did not know about that. So you're saying that if I write a regular expression that says foo something, and then I do this, you're saying that I get a local variable called something. That is amazing. Yeah. I had no idea. I mean, that's slightly gross, but it's amazing. Yeah, I mean, what I was saying was that I couldn't think of a way to implement. I guess I don't actually want the match data. I just want the named capture groups. But yeah, it doesn't look like it works in pattern matching. But that's amazing. That was definitely worth a try. Thank you. And yeah, unsurprisingly, that's a Kevin Newton special, is it? Well, thank you, Kevin Newton, for knowing more than any other human about the weird edge cases of stuff that happens in Ruby. I mean, this is basically immoral that this works. Like that really, it feels like something from Perl. And I mean, it probably is something from Perl. But it would be amazing if you could use that in a pattern match. So yeah, if you could just pass on to Kevin if he could just submit a patch for Ruby 3.2 that makes what you suggested, which I now realize is completely sensible, make that actually work in pattern matching, then that would make me very happy, because then I could get rid of this gross regex last match. Anyway, all right, I'm going to stop refactoring and cleaning up and stuff. I'm going to get onto the main event, which is that I'm going to try to make a new file work. And the file that I'm going to make work is... Oh, right. Hi, CVE. Thank you for your excellent comment, which I talked about at the beginning if you didn't see it. Right, you could do that in Elixir or in Erlang. Yeah. Yeah, I think Ruby has to... I won't get too distracted by talking about Ruby pattern matching. But yeah, I think Ruby pattern matching has got a ton of promise that is not fully realized at the moment because of shortcomings like that. I mean, I'm prepared to accept that I just don't know how to do that in Ruby pattern matching, but I don't think there's a nice way of doing it. Anyway, this is the file that I want to be able to evaluate. Yeah, thanks, CV. It'll be very useful when I do my next stream of re-implementing all of this in Erlang. I'll definitely make sure I use that feature. So yes, so now that I've got I can correctly interpret, I hope, all of these integers. Now, well, so this file is intended to test the implementations of these instructions, I believe. I32 operations is the extremely comprehensive comment at the top of this file. So this is testing that you have correctly implemented addition, subtraction, multiplication, two flavors of division, two flavors of remainder. I assume these are sort of bitwise, and or exclusive or. It's starting to get a bit more alphabet soupy. I'm assuming this is shift left, shift right, signed, shift right, unsigned, rotate left, rotate right. These are all bitwise operations. This is probably count leading 0, count trailing 0, I would guess. I mentioned last time that I recognize that one at a glance as being population count. I'll explain what these are when we get to implement them, or we can look at the spec and it will explain. That's probably a better. I'm sure the spec is better explaining these than I am. Not sure what these are. Anyway, there's some comparison stuff down here. So that's ostensibly what this is testing. However, well, we've already implemented add. So, you know, in a fair world, did I not save? Okay. Yeah, if the world was a fair place, I would be able to just say this, but instead of int literals, I could say int i32.wast, and at the very least, that first one would pass. But sadly, it doesn't, because the world is not a fair place. And this file that ostensibly tests the i32 operations is also implicitly testing your ability to take parameters in functions. So we're going to have to cross that bridge now. We're going to have to... So, you know, this is completely unnecessary, but it's fine. It's just more interesting stuff for us to implement. So this, rather than... it's not completely unnecessary, is it? Because they do actually... I was going to say they could just call everyone once, but actually they're testing... Okay, I take it back. This is necessary because what you don't want is a combinatorial explosion of function definitions up here. It's totally fine that they've parameterized it so that you can check that adding 1 and 1 gives you 2, but that adding whatever that is to 1 gives you that. So yeah, we're going to need to, just to get this first one, or this first chunk passing, even though add is already implemented, we're going to have to support invoking functions with arguments. So let's get into that then. So this is complaining about the fact that when we find function definitions, at the moment we're expecting specifically to find export with a function name, result with a result type, which we just ignore at the moment, and then a body. But this one has got parameters in the middle. So what do I want to do? I was going to say this is going to be a find pattern, but it's not actually. I think I can just say splat parameters here. So this is going to... The reason this isn't a find pattern, even no one will care what that is. This is just going to slurp up all the stuff in the middle, right? Like this matches right at the beginning, and these 3 elements are at the end of the array, and then this just matches whatever's in the middle. So it doesn't have to... It's a find pattern when... Well, if we had more than one of these splats and it was having to sort of try and figure out like where to match this in between 2 sets of splats, for example, or if there wasn't this thing that takes you right up to the end of the array, it would have to make a decision about where this matches. But that doesn't apply in this case. Just ignore everything I just said. It was all nonsense. No matching pattern error. So this is complaining about a different one now. Func export add param. Thank you, Ufuk. I have done this in the wrong place. I've done it in the wrong place. First, of course, as any fool knows, first you export the name of the... I mean, are they necessarily in this order? I had a look at the grammar yesterday and saw what order these come in. So I think they are always in the same order, but certainly in this file, export comes before the parameters. You are correct. Okay, great. So now we've got a different problem. And the problem is no matching pattern error. Yes, because similarly, this thing that matches invoke only expects to find, it just expects to find the name of the function to invoke, because that's all we had in literals. These were all just nullary invocations of these functions, but now they take arguments. So just as I added parameters to there, so I can, in a nice piece of symmetry, add arguments to here. And of course, we do use the different words, arguments and parameters here. Arguments are the values that get passed into the function, and parameters are, well, at the very least, the names of the local variables, or the parameters, if they're distinguished in this language, I don't know, that get bound to the argument. So there is a distinction here, although, you know, most people are not pedantic enough to distinguish them, because there's very rarely any advantage in doing so. But, you know, pedantry is not about practical benefits. It's about being correct at all cost. Okay, so this is going quite well. I mean, I realize I'm very aware that I haven't done anything with those arguments or parameters, but let's just chase these errors. So this is now saying, oh, well, now I'm going to have to do something with them. This is saying, I don't know what to do with an instruction like this. So down in evaluate, I'm just trying to think where this goes, but I guess I'm literally just pausing to decide whether I want to put it at the top or the bottom. I mean, I think over the course of this stream, this code is going to grow and get a bit long. So I'm going to do it here. So the problem we're having is that it doesn't know what to do here. So let's support that. Local.get name. Okay. Okay, right. So now this is basically this is basically working. This is returning nil, but you know, if it was returning, I hope Matt Valentine House is watching, that's for him. Yeah, okay, so now I'm saying, like, whenever you need to get a local variable, always just return a dummy value, and then this is actually one of these assertions is failing. Expected 2 got 84. Why? It's this very first one. So we've made a bit of progress there. So what we have to do now is arrange for the correct value to make its way down to here. So I can see we're going to have to inject something into it, because at the moment evaluate just takes an expression. We need some kind of context in here that allows it to look up these names and get their values. And we need to populate that with we need to populate it with the correct parameter names and argument values. So we need all of this stuff that we've added up here. But before I do anything else, let's just commit this, because that is a completely harmless change. So so let's say match parameters and arguments in function definitions and invocations. And I will just clarify that we're not doing anything with them yet, but this allows us to recognize them when we see them. I am less inclined to commit this because it's nonsense. So I'm going to leave this for now, although I guess that the problem is that there isn't a sensible return value I can put in here. So even though this is a similar kind of deal in that it's allowing me to recognize this instruction, I actually don't have anything sensible to return there. So I don't want to commits something that's just returning a bogus value there. So so I think we're going to have to actually bite the bullet and deal with this. So what do these actual parameters look like? They look like param, and then its name, and then its type. So I mean, we really only need to know its name. I'm thinking about whether I want to bother making it, like I made a struct for functions up here because I needed to package together the name and the body, whereas for parameters, I really just need the name. But I mean, I can see that it's going to, am I going to need the type? Let's just do it anyway. I know this is a little bit unnecessary, but I sort of want it to look similar to this, because if it looks different, it sort of seems like it's different for a reason. And I think it's kind of nice to have some classes to model these things, if only so that I don't lose track of, well, I was going to say lose track of what I'm trying to do, but there's no guarantee that this is going to prevent that. So let's say if for each of those parameters, if I map over them, what do I want to do here? I'm just trying to think of the nicest way to deal with this. I mean, I guess I could do pattern matching again. Like, it's pretty tempting, isn't it? It's just that I don't really want to do that. Oh, screw it. Let's do it. So what I'm going to do is say, this parameter, each of these parameters has to look like param, and then the name, and then the type, right? So it just has to be this. Param, name. I actually don't care about the type, and no, I'll just put in a placeholder for that. So this will, if I do this, then that doesn't raise an exception. And when I ask for the name, it will have matched this thing in the middle here. All the way, I haven't really talked about this explicitly, but like all the way through this, I've been really keen for this whole thing to fail fast, because I don't want to be in a situation where something is silently doing the wrong thing. So if it turns out that actually what we've got here is, something else, not a param, a baram, then I want to see this exception. So that's why I'm using that particular syntax there. Whereas I could have just reached in and said, give me element number 1 of that array, because all I really need is the name. So I can say parameter dot new name. See you, Fook. Thanks for coming. So that gives me my parameter object. And I suppose I might as well actually just make this parameters equals, like I'm just going to reuse that local variable, because that then allows me to, well, I'm going to add, I suppose this is what I should have said, I'm going to add parameters to functions. So the reason I'm doing all this is because when we invoke the function, we need to know what the names of the parameters are, so that, because ultimately they're fetched by name. So this local.get does not say, give me parameter 0 or parameter 1, it actually refers to them by name. So we have to store away the names of the parameters at function definition time so that we can make a mapping from parameter name onto argument value at invocation time. I'm sorry, I thought all that in my brain, but I didn't say it with my mouth. So this whole thing that I've just done shouldn't change anything. We should still see the same failure. Couldn't find function add. Why is that happening? Oh, have I done something wrong? I don't know what's happened there. So does this still work? Couldn't find function add. I'm not sure what I've done, because I was expecting to see that. At what point did it go wrong? Is it when I put this in? Yeah. Oh, it's God. It's because I've overwritten this. Stupid. That is very silly of me. So yeah, a bit obvious in hindsight. Although, I mean, should Ruby work this way? Arguably not. But what's happened is that I've accidentally reassigned this local variable. This is supposed to be the parameter name, not a replacement for the function name. So this occurrence of name is clobbering that one. Yeah, well, Kevin, that's no better than regexbot.lastmatch, is it? Like, Kevin's saying I should use $tilde to access the match data, but that's just a even more gross way of doing this, isn't it? Okay, same thing. All right. Well, I appreciate the option, but actually I think that's even more disgusting than writing regex last match. I mean, they're both equally bad, right? But at least this one is in the English language. Anyway, speaking of gross, I've got a horrible choice right now. Well, I've got two horrible choices and one nice choice. The nice choice is to extract a function that does this, so that it doesn't matter what I do, because it can't clobber any local variables, but I can't really be bothered to do that. So I've got two choices. One of them is that I pick a different name here, and then that means I can't use hash punning down here, which is a bit gross. The other option is to make a block local variable here, which I think is a feature that this is a sort of Kevin Newton flavor Ruby feature that probably a lot of people don't use, but it exists for this reason, right? If I want to use a variable in a local variable inside this block and not have it pollute the outer scope, I can like declare it here, and then it becomes local to the, yeah, Kevin's saying I could just rename this, but again, then I can't use punning down here. Like I'm quite committed to using hash punning down here. So really it's the punning that's causing my whole problem here. But I think that unbelievably, having a block local variable is probably the least gross solution to that. So I'm going to go with that for now. And I've actually got a commit there, which is something like remember function parameters at remember parameters at function definition time. So that's okay. I'm just going to briefly say I'm using a block local variable here so that I can reuse the name in order to be able to keep using hash punning. It might be better to just extract the map so that I don't have to worry about the blocks polluting the outer scope of names. So I'm going to add that to my extract parameters.map block from interpret, so that I don't have to use block locals. I'm not sure whether that's worth it, but I'm going to leave that on my shit list and decide later whether I'm going to come back to it. Okay, so we've remembered the parameters, and so now I've been sort of avoiding doing this because it's going to be a little bit gross. But okay, so when we invoke the function, we've got the arguments, each of which is an expression. So what we need to do is evaluate these expressions and then associate them with, sort of point-wise, associate them with the parameter, and ultimately pass them into evaluate so that their values are available in case we want to do local.get, which indeed we do want to do. So where's the best place to do that? I mean, I have to do it before here. I'm going to break out this, I'm going to break, this was just like next to expected value, but now there's going to be a little bit more work involved in evaluating the function body. So what am I going to call this thing? Environment? Maybe locals? I think maybe calling it locals is like if I had some hash here that was mapping parameter names onto their values, then I could just use hash punning to pass that into evaluate. Locals is like a little bit of a does what it says on the tin kind of name. This is not going to survive very long because it probably won't work for anything more complicated than what I'm doing right now. So I'm going to go ahead and just give it does what it says on the tin name, so that, because if I give it a sort of a highfalutin name like environment or context or something like that, it sort of makes it sound more legit than it actually is. It's actually just a piece of junk that I'm going to be cobbling together right now. So the way to do this, I think, is I can just use zip, because I've already got the function. So if I do function.parameters and I zip it with arguments, I'm hesitating because I don't actually want the arguments. I want the values of the arguments. Okay, let's do that then. Well, let's say if I had argument values, so that's going to give me an array of 2-element arrays. Sorry, I said I would be more forthcoming with what it is I'm talking about. So zip lets you combine, well, any number of arrays, but let's say 2 arrays together into an array of pairs. This may be less illuminating than just doing an example. So if I do 1, 2, 3 zip A, B, C, then I get this array of pairs. And what's quite nice about that is that I think I can just call to H on that, and I get it treats this list of pairs as like key, comma, value, key, comma, value, key, comma, value, and that gives me exactly what I want. So I can just do that here. I can just zip these 2 arrays together and then say to hash and then pass the locals in. So that's actually not so bad. But before I do that, I need to say argument values is equal to, this is painful, isn't it? Arguments.map evaluate argument with no locals, I guess. Like that's sort of what it suggests to me. I just realized that's a keyword. Yeah, I mean, I'm not very happy about having to pass in an empty hash there, but whatever. So this sort of feels like it might not be wrong. I'm just trying to think about what's a good order of operations here. With respect to making a commit. Because there's a whole self-contained change that's just adding this locals argument to evaluate. I'm going to stash this and do that first. So I'm going to say this takes a required locals argument. And we're going to basically need that wherever evaluate gets called. So this is not, it's not great, but where else do we call it? Well, for now, this is going to have to be the empty hash. I think that's it. It's not that bad, actually, because we're quite early on and there's only 4 call sites for that. Fine. Okay, add required locals argument to evaluate. And then I'll say this is a hash which maps parameter names onto... Oh, it just occurred to me I was assuming these were names, and actually I didn't pull out the name of the parameter when I did that zip, so I'll go back and fix that in a sec. This is a hash which maps parameter names onto argument values, which we'll need when we implement the local.get instruction. Okay, so now I do not need your stash anymore. Oh yes, fair enough. You're right, I did make a nearby change. Get. So what did I do? Oh, well, like I just said, I haven't actually done what I said I would do. Okay, well, let's do parameter names equals parameters dot map name function dot parameters. Hello, Chris. Thank you for joining me / us, depending on whether or not you're the only person here. I don't know if Kevin's still here or CVE. So this is now parameter names. I mean, I assume that it's only names that we need. There wasn't really anything wrong with mapping the parameters, except it just makes it more annoying to look them up. So this isn't so gross. Parameter names, we get them from the function parameters. Argument values, well, we've got the arguments because we're invoking a function right now, and we're going to evaluate all of them. Again, I feel it's a bit gross that we're evaluating them in an empty collection of local variables, but that's life. And yeah, then we zip them up, turn them into a hash, pass them into evaluate. So this hasn't improved our lot, but this should work, right? Yeah, same situation. But now I think we're ready to do something magical. Oh, by the way, I just glossed over the fact that we evaluate these before we pass them in. Maybe I should have talked about that a little bit. Like, that's a design decision, and I don't know whether that's right for WebAssembly, but I bet it is. You've got two choices. One of them is that when you invoke the function, or rather before you invoke the function, you evaluate its arguments and then pass in the resulting values. That is what I am doing. Call by value, essentially. But there's nothing technically preventing me from, instead of passing in the value, I could just pass in the expression, and then when we implement local.get, we could evaluate the expression at that point. We could look up what expression corresponds to parameter x, and we find out it's i32.const1, and then we evaluate that to get a value. But that's more unusual, and that's why I just defaulted to evaluating those arguments first. Like I say, I'd be extremely surprised if that wasn't the correct choice, but I also can see that there's nothing in this file that makes any difference either way. There's nothing in here can have a side effect, for example, and so there's no way to know. This file does not specify what the sort of evaluation semantics of invoking functions is with respect to evaluating the arguments, but I'd be so surprised if it's not what I assume it is, that I'm just going to plow on and hope that I'm right. So this is just locals.getName, except it's not get, it's fetch. But I wanted it to be get because this is local.get, and I thought, it'd be great if we could just recapitulate this, but you can't. Yes, look, 2 equals 2, 1 equals 1. Indeed they do, my friend. Oh shit, something's gone wrong here. Okay, that's annoying, but look, this is working fine. So there's definitely, I think, 2 commits there, because there's this one, which is pass parameter names and argument values into evaluate. Let's say provide parameter names and argument values when evaluating function bodies, because that's what this is doing. It's evaluating a function body, whereas here, for example, we're not doing that. And then this is the kind of, how did I say this before? Oh yeah, it's just like implement the local.get instruction. Yeah, so that just works. I'm somewhat annoyed to see that, like, what I wanted was for it to just blaze through all of these ads, and then I was going to triumphantly say, oh, now we just have to implement sub. But tragically, that is not the case, because something has gone badly wrong here. Okay. I think that what's going to have gone badly wrong here is, as I mentioned yesterday, that we need to think about overflow, and I haven't thought about overflow, and I'm almost certain, because this has failed on the negative numbers, I'm almost certain that what's happening is that the result of adding these two, the unsigned representations of these two signed values, is going to overflow and give us a number that's larger than 32 bits. And I don't think I'm doing anything about that, and that is going to necessarily not be equal to the 32-bit representation of -2. In fact, it expected this number. So let's do sprint, just in anticipation of my explanation. Let's print this out as a 10-digit binary number. Oh, no, of course. It's all of the examples I gave last time were bytes. And so I thought, if I do 10 binary digits, that's more than enough. But of course, these are 32-bit. So let's make them 34-bit. Okay, so that's what I was expecting to see, is some zeros at the top. So that was supposed to be the answer of adding -1 and -1 together. And again, we can assume that that's 2 to the power of 32 minus 2. Yeah. So that's what we were supposed to get, but instead we got this. And yeah, if my theory of what's gone wrong is correct, this is going to look very much like this number, but it's going to have overflowed. Yeah, so that's exactly what I anticipated. It is the right answer in as much as the least significant 32 bits are correct, but unfortunately I haven't done any work to make sure that we don't venture into more significant bits than that. So that is clearly incorrect, and in my defense, this is a problem that I anticipated yesterday, but in the prosecution's case, I didn't actually do anything about it. So what I'm doing right now is that in interpret integer, I do the work to mask this value before it gets returned. So in terms of actually reading integers from the literal source code, this gets, and mask here is just masking off the bottom, in this case 32 bits, to make sure that we don't get. I had to put this in specifically to deal with -0, but it's also useful to have it in there just to deal with if someone had written a number that was too large in the source code. It feels like this is a sensible failure mode, is just to lose anything above the bottom 32 bits or 64 bits or whatever. But I haven't done anything for add. I mean, I can tell you now that I could fix this by just saying mask that value to be the appropriate number of bits. So do the addition and then mask off the bottom 32 bits in this case. And I'm going to stake my reputation on the fact that this is going to get at least a little bit further than the first two examples. My reputation, such as it is, has survived that challenge, because we have indeed gone further, and this is what I was expecting, was that we were going to fail on sub because I haven't implemented that yet. So that's sort of quite good in that I've understood the problem and fixed it. But I can already anticipate that this is going to get really annoying, because, next I'm going to be doing in sub, whatever. And I'm just going to have to put mask around it again, which maybe I should just do and not anticipate future problems. But I can sort of see a nicer way of doing this, which is to just always do this, say like result equals case expression, and then mask the result. Oh, no. Sorry, that's in the wrong place. Because we only have the sense of how many bits the result is when we're inside one of these instructions that is sort of syntactically saying the result is 32 or 64-bit. So it would be inside here, right? Result equals blah, and then mask result bits. And then I don't need, not only do I not need to do what I did, But I think, unless I'm missing something, I think that sort of absorbs this use of masking as well, because this means that not only, this applies to the result of interpret integer, and it also applies to the result of the addition here. So I think I like that. This is a bit gross, isn't it? Why don't we write it like this? Well, just do this here. And that's a bit... Is that gross? I mean, it works. If you're not familiar with that. This is a method that's available on all objects that just yields whatever the object is, it sort of yields it into the block. So essentially it's avoiding the need to assign this to a variable, because the assignment sort of becomes, it gets assigned to this block parameter instead. But to me, this is a nicer way of like chaining some, massaging or modification of the result value. And that's exactly what I want to do here, is like I want to do whatever this case statement is doing, and then I want to do something to the result. I think, is that too? I said I wanted to prioritize clarity over cleverness. Is this too clever? I mean, it's not particularly clever, but it's maybe a little bit obscure. No, I think I'll allow it. I think that's all right. It's idiomatic. Yeah, that's fine. That's fine. Don't worry about it. That's my advice. Just don't worry about what I'm doing. Thanks, Chris. I appreciate your support for this decision. So I want to commit this. Always mask the result of an I32 or I64 instruction. I'm going to say we know the result has to be a 32 or 64-bit integer, so we can so rather than separately masking the results of each individual implementation, we can just do it once here and get the benefits everywhere. I think that's reasonable. And then, so this is remove unnecessary masking from, what's this method called? Interpret integer. I just shouldn't call things names that contain interpret, because I just can't type it. Now that we're always doing this in evaluate, there's no need to do it here. Now is this, I'm just going to double check my assumption here, because that is true, but is it ever going to be problematic? Like, will there ever be a caller? Implicit in what I just wrote there is that I'm expecting this here is gonna be the only caller of interpret integer, that like you're not going to call this somewhere else for funsies and then do something with the result value. I think that's right, but I mean, and I think it's more clear to have this one place where we mask the result rather than Maybe I should call it value rather than sort of sprinkling them around. What's the right word? You know, without really thinking about where they're needed, but just say like, oh, maybe if I put a mask in this function, it will help. Like, I'd rather just have it in one place. All values get funneled through that place. So when you evaluate something, the last thing that happens to it is that it gets masked off to be the right width. I think is cleaner conceptually. So yeah, I'm not going to worry about it. I'm going to allow it. I wish I'd called this value though. So I'm going to call it value. Yes, it is that. Does it still work? Yeah. And which commit was that? It was this one, I believe. Yes. So I'm going to do a git fix up of that commit. And then do an interactive rebase. And now no one will ever know any different. Okay, cool. All right. So that's good. We've successfully, at least for the purposes of add, we've successfully implemented argument passing, and we're now successfully using the implementation of addition that we had last time, which has admittedly been a bit of a slog to get to that point, but we're now ready to implement some other operations. So let's see how easy this is. I mean, this I hope is going to be easy. Sub tract. Amazing. Okay, let's see how long this streak can last. And I mean, you know, maybe I should be thinking about how to reduce this duplication, but I just want to see how many of these I can implement first, and then we'll think about it. Yes, I've already gone wrong, haven't I? Oh, okay. What's this? Assert trap. Oh. Okay. So this is a kind of assertion we haven't seen before, and this is checking that if we divide by 0, then a bad thing happens. I don't know anything about how to make a bad thing happen, and it's not really what I wanted to think about at the moment. So I'm just going to put that in here. Sorry. I just want to focus on assert return. I just want to compute values and get them right. Like, I'm going to try and be single-minded about that goal. So yeah, this is what I expected to see. Div S. So I mean, I realize I haven't looked in the spec to find out what add. Well, I didn't actually look in the spec to find out what add was, or today I haven't looked to see what sub or mul or div S are. I think it has been demonstrated that sub and mul must be subtract and multiply. I mean, let's have a look. Yeah, they are. Well, I mean, I don't know why I was looking there. I've demonstrated it here. So this is div S. Now, annoyingly, I mean, I think that div S is going to be signed division, and you can see that some of these have got negative numbers in them, whereas here are the unsigned ones. It would have been more convenient for me if they put this first, because I think unsigned division is going to be the easier thing to implement. But unfortunately, bad things happen to good people, and therefore I don't get to try this first. I have to try this. So the reason I'm taking a deep breath about this is that signed division is really annoying because of a lack of consensus over what it means to divide, well, to divide numbers where either of them is negative, basically. I mean, if we get really lucky, then this is just going to magically work. But this is one of those things that experience tells me is extreme. You know, life is not good enough for this to just work. So let's see. Okay. See, the problem is I don't actually know which one this is, but I assume it's, well, I know that it's one of these divs because the previous error was I don't know how to do div, and now we're not getting I don't know how to do div u, we're getting an assertion failure. So one of these has gone wrong. It's going to be, well, I was going to say this one, but this one's dividing 0, but it's probably going to be this or maybe this. I mean, I am at least a little bit curious which one this is, so let's just temporarily let's put the, I'm just trying to think, how do we, I just want to have something that tells me which one we got to. Okay, so this was dividing this number by 2, and this number is the unsigned representation of what's going on? What am I missing? Is it this? Yes. Okay. I was expecting it to be a small number, but I guess it's this one. Okay. All right. Rather than just like randomly mess around with this, I'm going to actually think about what is happening here. So that, as I was sort of intimating, signed division is really annoying because, like, with integers, because it's sort of obvious what 4 divided by 3 should be in the world of integers. It's like, well, it's 1. There's 1 3 in 4, and then there's a bit left over. And in fact, we can ask how much is left over. Oh, there's 1 left over. That's pretty well defined. But if you say, how many 3s are there in -4? Well, I mean, if we take -4 as a float, I mean, of course, division isn't really how many. It's the inverse of multiplication, right? So here we're saying there are -1.3 3s in -4. That's what you would expect. And then, the identity being that if you then multiply -1 1/3 by 3, you get -4. So that all works fine in the world of floating point numbers, but in the world of integers, it's a little bit less clear. And in fact, is a matter of interpretation what you think the answer to this should be. And this always trips me up about Ruby, because Ruby in particular doesn't do the thing that I expect, which I suppose is probably the problem here, which is that the expectation is that this is it's gonna have to round to an integer, right? Because this is an operation on integers. but I think it would be reasonable to expect that it would round to -1 because that's the nearest integer. But I'm pretty sure that Ruby truncates towards negative infinity. So this is actually going to be -2. So it's a little bit surprising that -4 divided by 3 is -2. And I expect that what's happening here, although I haven't investigated it, is a manifestation of the same problem. Well, let's think about it. This was... Okay, so this is saying that that number divided by 2 is equal to that number. And I think I was correct when I said that this is the unsigned interpretation of the number minus blah, 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 blah. So let's do the math. Minus that divided by 2 gives us -1073. But what is the expected result? Oh, that's the same. So what's the problem? I was so pleased with myself, but I was wrong, as is so often the case. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, it is this one. So it's saying expected this, got something else. I'm not sure I understand what's gone wrong here. I guess I need to do some more debugging. Maybe it'd be better if I just show the arguments, because seeing the interpreted ones is sort of a bit less helpful. Yeah, okay. I'm just going to do some puts debugging. Well, I'm already doing that, aren't I? Let's see. So this is saying... So let's evaluate these. And then we'll say left divided by right equals... Well, let's have a result. Well, I've just realized a more serious problem. Which is that I'm not interpreting any of these as signed numbers. So that's almost certainly the problem. It completely slipped my mind that we're representing all of these as unsigned numbers. So, you know, what I was doing in IRB just then was I was going to the trouble of interpreting these numbers as signed and then getting the right result and wondering what the problem was. But I think the problem is none of these are being treated as signed numbers. So it's lucky that -1 divided by -1 is actually the same as 42949679295 divided by itself. But that's just a coincidence. Well, it's not a coincidence, but it's fortunate. Okay, all right. Well, at least I finally understood what the problem is. I went down a bit of a rabbit hole there, worrying about division of negative numbers, and I'm still pretty sure that that's going to be a problem, but there's a bigger problem here, which is that left and right here are both unsigned, and we need them to be signed. So really what I need to do is something like this. You know, maybe they call them signed left, signed right. You know, we need to evaluate, because these are expressions. So we need to evaluate the expressions. And then we need to convert them to signed numbers. And then we need to do like signed result equals signed left divided by signed right. And then we need to, the whole currency of integers in our implementation is unsigned. So we're going to have to, this effectively, we like step into the world of signed integers, we do a computation, and then we step out of it again. So the result is going to be convert to unsigned the signed result. And I haven't actually defined these functions, by the way. I'm going to need them. But I think this is the sketch of what we need to be able to do is like, yeah, like I say, sort of temporarily step into the world of signed numbers in order to do the computation in Ruby, which is this division, and then step out of that world again and return the result. In fact, I'm way overdue to check my assumption that this is what div s actually is. So let's have a look. Execution, numerics, integer operations. Oh, see, I looked at this a bit. Oh, excuse me. I looked at this a bit last time. This is where I was talking about a function being bijective and hence invertible. But this is actually the function that I need. This is what I'm talking about. I need to call signed to convert. Let's just record that that's what that is. Signed takes an unsigned integer and returns a signed one, and then we need the opposite of that. Now, I was saying that I don't think they provide the inverse of this function. They just say the inverse exists because this function is bijective. But, you know, we're intelligent people. We can figure out what the inverse of this function is. Anyway, what was I doing? I was looking up. So, yeah, look, that's div u. That would be easier, wouldn't it? So I'm not sure where the connection is established. Maybe it's inside text format here, between the instructions in the program and these sort of mathematical definitions of these operations. I don't know if there's, in this text format, is there some kind of numeric instructions? Does this define the mapping that says the instruction i32.div? Yeah, oh yeah, okay. This is exactly what this is the table whose existence I was in the middle of hypothesizing. So yeah, this says the instruction i32divs corresponds to, well, there'll have to be something somewhere that explains how to map this onto this idiv s sub 32. But okay, that's good enough for me. So yeah, this is exactly what I was, again, I should have just come and read this first instead of, you know, trying to fashion it from whole cloth using only my mind. Like this specification exists and I should make use of it. So it says, if you want to do the integer division of the signed interpretation of two. So I think this I meta variable ranges over uninterpreted integers. It doesn't say. It doesn't talk about the meta variable I. At least not on this page, but I'm pretty sure that we saw last time, and I tried to come up with that mnemonic, that S is for signed integers, U is for unsigned integers, and I is for uninterpreted integers, which is like generic integers. So this is saying that the signed division of two uninterpreted integers is that you take the signed interpretation, which again is this signed function. So that's exactly what I'm doing. Take the signed interpretation of, in this case, the result of evaluating the left and the right operands here. Take the signed interpretation. If it's 0, then the result is undefined. Yeah, we're just skipping the assertion that's checking that we produce an undefined result here, because I don't want to think about how to do that yet. Else, if j1 divided by j2 is 2 to the n minus 1, then the result is undefined. What case are they worried about there? I'm not sure why that's there. Anyway, this is the important thing. Else, return the result of dividing j1 by j2 truncated towards 0. That is the opposite of what Ruby does. Ruby does not truncate towards 0. It truncates towards 0 for positive numbers, but for negative numbers, it truncates away from 0. It always truncates towards negative infinity, but negative infinity is only towards 0 if you're above 0. Otherwise, it's away from 0. So we've got two problems. Number one, I've got to define this function and its inverse so that we can step into the world of signed numbers, do the computation, and then step back out into the world of unsigned numbers. And the second problem is that this division is not actually going to give us the right answer in all cases. But we haven't even seen that yet, because it turns out the problem we were having was that I wasn't even trying to compute with signed numbers. So let's try and define these. Signed is nice and easy because it's literally written in this file. How have I lost it already? Okay. Yeah, okay. So what this is saying, I was going to say not so many words, but it does say it in these words here. What this is saying is that if the most significant bit of the number, so imagine this is, if we were thinking about 8-bit numbers, if the top bit is 0, 1, 2, 3, 4, 5, 6, 7, this is the largest number where the top bit is 0. So if it's 127 or less, and notice that 127 is 1 less than 128. So if it's less than that, then leave it alone. You know, this is the identity function. It just returns the uninterpreted integer again. So it's saying, like, if the top bit's not set, then you've already got the signed representation of your number. But if the top bit is set, so if it was, 1, all the zeros, 129, then we have to convert it. This looks like a positive number, but we've got to interpret it as a signed number now. And the way we do that is by just subtracting it from, I was going to say the maximum number, but it's actually, 1 more than the maximum. Subtracting from it, sorry. So we'd have to do 129 minus 2 to the 8, and we get this represents minus 127. So we can just type that in. What I'm going to do is say this value here, 2 to the n, I sort of want to call that the size, because it's how many distinct values there are. It's like if you've got an 8-bit number, how big is that? How many different numbers can you express with 8 bits? And the answer is 2 to the 8, 256. And we need that number here. So let's say size is, oh, of course, this is all with respect to how many bits we've got. In the maths, that sort of gets obscured with these subscripts, but this is parameterized on how many bits we have. So I'm going to need to do that all over the place here as well. So size is, let's again, I think as I did in the masking thing. Oh, look, this is size here as well. I'll do that while I remember. Oh, and that gives me the benefit that I can use fewer parens here. Okay. Anyway, so once I've got this, what's the logic? If it's less than, so this is 2 to the power of n minus 1, which is actually half of the size, right? When the value lies in the upper half of the value range. So I'm going to say if unsigned is less than size over 2, and I know I'm being a little bit hypocritical here by shifting this to get the size and then dividing by 2, but this makes more sense to me. I don't know why. Sorry. So we just return unsigned in this case. Else, we return unsigned minus 2 to the n, which is size. So I think that's right. Let's try it out. Okay, so according to this, signed of this number treated as an 8-bit value is minus 127, whereas signed of this number treated as an 8-bit value is 127. I think that's right. But of course, we'll only really know when I've also done this one. So this is the stressful part. We've got to think about what's the inverse of this function. It's not really stressful, is it? I essentially already implemented it here. I've got to remember here that magnitude is a positive number, but essentially what this is saying is we're going to need size again. So we've been given, now we're doing this the other way round. Someone's given you minus 127 and they want to recover this value, 129. And I think the way that we do that is we just add it onto that size, you know. Yeah. And that's what I'm doing in interpret integer, is I'm adding the negative number. So I'm subtracting the magnitude of the number, which is a negative number. So I'm essentially adding it to the size. So it's going to be something like, you know, signed plus size, but only if this is a negative number, because if you gave me, because of this half of the forward function, the bijection we started looking at, because it's the identity for half of its input range, we have to make sure that this inverse is also the identity for half of its input range. And in this case, the half of the input range for which this function is the identity is all of those values where the top bit is 0. So for the small half of the inputs. Whereas for this one, it's all the negative numbers, right? So if this should be if signed negative, then do this. Else, it's just going to be the identity, I think. I haven't run this code for ages. Let's just sense check this in IRB before I try anything. So this needs to be the inverse of this signed function. So I should be able to say unsigned minus 127 as an 8-bit value gives me 129, which I think is what I started with. Yeah. And unsigned of 127 as an 8-bit value is just 127 because that's in the identity half. Okay. That sort of looks okay. What happens when I run this? Okay, well, the good news is we got further. So previously we were failing on this one. And now we're failing on this one. So I think that means that, yeah, the reason why this was failing was because we were just treating this as a positive number and just literally dividing a big positive number by 2, to which this is obviously not the right answer because we would have expected to see a 4. Because there's an 8 in this. So here, all right, well, let's investigate. This is what I did last time and it was fruitless, but now I think maybe we can make some progress. In fact, why don't I do myself a favor and define these in IRB here? And then I don't have to type all that maths. So we've got to take the signed interpretation of this, and it's a 32-bit number. So it's minus blah, blah, blah. We have to take the signed interpretation of this, which looks too small to be a negative number. So that's just 1,000. Okay, so now we do this divided by 1,000. We get a smaller negative number, and then the unsigned representation of that smaller negative number is this. However, it's saying that it wanted this, which is a very similar number, but 1 greater. So if we look at the signed interpretation of what the expected answer was, it's minus 2,147,483, whereas previously it was blah, 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 484. And this feels to me an obvious case of not rounding towards 0. So let's look at what Ruby does. Okay, yeah, look. So the result here is minus 214783.647. Ruby is going to round that towards negative infinity when we do this division. So we get a 4 on the end, whereas, as the spec says, I've scrolled too far. Truncated towards 0. So how are we going to deal with this? I've always, this is another situation where it would be really convenient to just have access to the underlying instructions. Um, but I don't. I mean, the what the CPU can do, or to be able to do this in C. But I'm just at the mercy of Ruby's semantics here. So if I want to keep doing this in pure Ruby, I've just got to think about how can I do this. I guess I've got two options. Well, I've got more than two, but the two most obvious options are, number one, I could re-implement division. Just use an algorithm, just write an algorithm for doing division, which doesn't really appeal. The other option is just to fix up the result. Like, it's very close to being the correct result. So the circumstances under which this is going to diverge from Ruby's behavior is going to diverge from what WebAssembly expects is, I suppose the point is 4 divided by 3 is fine, because that is truncated towards 0, because that's what Ruby does for positive numbers. If I do minus 6 divided by 3, then that is also fine, because there's no remainder, like there is no rounding. It is exactly 2. And I suppose the way to say that is that minus 6 modulo 3 is 0. So in any case where the division is exact and there's no rounding, it doesn't matter that Ruby disagrees with WebAssembly about what direction the rounding should happen in, because there isn't any rounding. It's just when both things happen. So when there is some rounding, minus 4 modulo 3 is not 0. There's 2 left over from whatever the result of this division is. And the result of the division is getting rounded in the wrong direction. So it's being rounded towards negative infinity. So, and I assume this is the same if we do 4 divided by minus 3, we have the same problem, right? Because it's the sign of the result. It's the result that gets rounded. So it doesn't really matter. I'm just trying to work through this in my head. It doesn't really matter whether it's the dividend or the divisor that is, whether it's the thing being divided or the thing being divided by is negative. Doesn't actually matter. In fact, if they're both negative, it's fine, because the rounding happens in the right direction. It's just if the result is negative, it gets rounded. It's 1 smaller than we're expecting, because if any rounding happens and the thing being rounded is negative, it goes down, it goes to the integer below rather than the integer above. And so I think I'm talking myself into the idea that the most straightforward way to fix this problem is just to sort of post-process the result of Ruby's division. Look for this situation, and when this happens, just fix it. So let's do that. I'm going to do this. Did I get those the right way around? I think I did. I think it's dividend on top and divisor underneath. Does this care about bits and stuff? No, we're just at the level of maths. We're just doing a division. I'm just thinking, do I want to make a commit before I do this? I think I do, because I've already added tons of stuff. So let's do that before I completely get away with myself. Okay, well that's an important... what did I say before? Ignore the assert trap command. I haven't thought about how to raise exceptions yet, and I'd rather avoid it until I've got the basics working. That's fine, that's just the truth. I'm sorry to be so picky about this, but I'm going to do it. I'm going to do it this way. What did I say before? So implement the i32 sub and i64 sub instructions, because this applies to both of them, because we're inside that thing that sort of breaks apart the instruction and parses out how many bits there are. So we kind of got two instructions for the price of one here. And then this is practically the same thing. It's just mul. Did I do the right thing there? Yeah. Okay, so we're kind of whittling down. Yeah, I think that there is value in committing this. You know, this is pretty close to being right. Begin implementing. I was just thinking I want to just add these helpers. Signed and unsigned helpers. We need to convert integers between signed and unsigned representations so that we can implement instructions like i32 dot div s. Is that what it's called? Yeah. So we need this pair of helpers first. And this should be in order to okay, that's fine. And then I'm going to add my use a size local variable in mask. This matches the same variable in signed and unsigned, which makes it clearer that we're calculating the same value for the same purpose in each case. Okay, so now I will add this and just say begin implementing i32.divs and i64.divs. And let's say this isn't correct yet because WebAssembly division, signed division, truncates towards 0. And we do actually have a citation for that here. Whereas Ruby's division truncates towards negative infinity. So the result of Ruby division, so the results of Ruby division aren't always exactly correct, but it works sometimes. Okay. So now we can do what I was going to do, which is implement this. So first we need to take the result of doing the division, which is called the quotient. Now what we're going to say is, like, if the quotient is negative and the division wasn't exact, then we want to return quotient plus 1 to sort of correct the fact it's been rounded down instead of rounded up. And this is like else quotient. Well, I guess it would have been just as easy to write this as Ruby code. So if quotient negative and dividend mod divisor is non-zero, I think that's right. Why don't we ask the computer if that's right? Yes, amazingly, that is right. Because now we've hit div u. So even though that's a little bit of a bodge, it is actually right. That's good enough for me for now. Like I said, it's a shame that we're having to sort of do work here to undo Ruby's behavior when I'm sure there's an instruction on my CPU that will just do this and give the right answer. Because otherwise, why is WebAssembly semantics the way it is? But whatever. I mean, not necessarily, but whatever. I'm just thinking about whether I want to clear this up. Clean it up. No, I think it's fine. Just thinking, like, should I inline signed result here? But no, that's okay. I'll leave it like that for now. It's not really necessary for it to be that verbose, but so now let's say fix division results for inexact negative quotients. And let's say per the previous commit, Ruby rounds towards negative infinity, but we need to round towards 0. So we need to add 1 to the result of division when it's negative and has been rounded by Ruby. Did I say negative 0 in the previous one? No, I said the right thing. Okay. All right, so it was failing on unsigned division, which I said was going to be easier. If the divisor is 0, then the result is undefined. Else, return the result of dividing I1 by I2 truncated towards 0. Makes me realize that I don't actually have... I haven't even tried to think about what this trunc function is. What's this saying? Oh, it doesn't matter. This is... I think this is just what Ruby division does anyway, so I think that'll be fine. Although, shall I use divide just for the sake of it? Because, like, it'll do the right thing. Yeah, I think I'm tempted to do that because this is essentially my divide with truncation towards 0 function, right? And it happens to be implemented in terms of Ruby division. But I might as well just use it directly here. So let's just say divide, evaluate, left, locals, evaluate, right, locals. Is that good enough? I guess so. That seems to have worked fine. I'm obviously getting a little bit sick of skipping those. I'll stash them for now. I'll want that back if it starts failing again. So this is div u. Okay. So what was next? Rem-s. I mean, I realize that this is now getting a bit tedious because I'm just going to be grinding through it. Okay, well, this is like signed remainder, basically. So we take the signed interpretation of both sides, ignoring division by 0, return the remainder of dividing one by the other with the sign of the dividend. Oh, God, is that what Ruby does? So what that's saying is if I do 5 mod 3, I get 2. If I do minus 5 mod 3, I got 1. Yeah, this might not be good, might it? Let's just whack it in and see what happens. In rem-s, left, right, I need these. Well, basically all 3 of these. But the signed result, let's just do the optimistic thing of doing this and then converting back to unsigned. But what happens in this case? As predicted, I wanted my... What did get stash apply say? Oh, yeah, well, okay. Just chill out. It's fine. So a bunch of these have worked. Remained assigned, remained assigned, remain assigned, but this one hasn't worked. Right. So that's clearly not good. How am I going to deal with this? I suppose I'm going to need a similar kind of thing, right? I'm going to need... So hold on, I need to think about the basic arithmetic of this situation. My example, 5 mod 3 is 2, minus 5 mod 3. Ruby says is 1. That's... right. Because Ruby's saying that minus 5 divided by 3 is minus 2. And that, you know, minus 2 times 3 is minus 6. And so the remainder is 1 to get us back to minus 5. What this is saying is return the remainder of dividing J1 by J2 with the sign of the dividends J1. So this is saying, maybe I don't even need to think about this. Maybe I can just implement it. It's saying, oh look, signed minus 1. So this is the inverse of the signed interpretation function. So this is our unsigned function, which is fine. So saying J1 minus J2 times J1 divided by J2. I mean, my brain's hurting a little bit trying to understand how this relates to what Ruby is doing with its modulus operator, but maybe that doesn't matter because we could just do this. I could just do this. So if I say, maybe I shouldn't have called this divide, maybe I should have called this quotient because I sort of want to call this remainder. Maybe I should call it. What does Ruby call this operator? Yeah, modulus. Well, calls it modulo, returns the modulus. Well, which one is it? Modulo. Oh, the result is called the modulus. I can never remember which way around this goes. Okay, so the operation is called modulo and the result is called modulus. I think it's understandable why one might get confused about that. Okay, so let's call this modulo dividend divisor. And let's just try this. So this is J1 is the dividend, J2 is the divisor. So this is dividend minus divisor times, and then this truncating division is divide. So this whole thing needs to be, well, it doesn't need to be, but for clarity, I will parenthesize it. So this is saying if we divide the dividend by the divisor, as you would hope, I mean, this is a nightmare, isn't it? Dividend minus divisor times divide dividend divisor. But that makes sense. This is saying if we do A divided by B and then multiply the result by B, so it's like how many B's go into A, figure that out, multiply that by that many B's, and then subtract that from A, and that tells us what the remainder was. So that does make sense. It's just that I can't quite get my head around how that's what Ruby's doing, basically. So let me change this. So now we do modulo dividend divisor. I mean, if this just works, I'm just going to walk backwards into the hedge and say that this is fine. Mash up. If anyone wants to make a GIF of those two memes mashed up, that would be great. Undefined local variable on method dividend. What have I done wrong? Oh, they're not called this. I mean, it looks like it works. This is fine. Walking backwards into hedge. I mean, yeah, it's worked. They've all worked. Now it's complaining about remu. Oh. So I can say, yeah, I mean, I didn't commit the intermediate version of this that kind of worked, but I think it's getting literally late enough in the day that I can't be doing with all that. So let's say what is this? Rem-s. Again, Ruby's semantics don't match WebAssembly's. So we need to implement modulo ourselves according to the spec. If I was a cleverer person, I would think a bit about what's going on here and try and work out like why Ruby's doing it differently and like in what way it's different. But like I said, it's getting relatively late. Just realized that these are different URLs. If you click on the paragraph thing, you get this horrendous long thing with loads of junk on the end of the URL. But if you just click on the instruction, you get quite a nice one. And I'm wondering, did I click on the nice one before? No, look, I clicked on the horrendous one. So let's just rewrite this commit message to use the nice one. Let's wait for the math jacks to swap in. There we go. Okay. Have I still got in my stash? I used apply, didn't I? Okay. So, I mean, I want to say we're nearly there. I don't know if we're nearly there. There's probably still loads of these to go. Remu. Well, I know how to do this. It's basically the same as this. It's just that instead of calling divide, I call modulo. Oh. Why is it... Again, so pleased with myself how quickly I did that. The only problem was that it was wrong. Oh, yes. Great. Great. So this is just remu. Fantastic. Okay, it was failing on and. So does and do anything interesting, or is it just literally and? The bitwise conjunction. Well, I think that Ruby's got that built in. So I think that's going to be more like one of these more conventional binary operations. But instead of star, it's going to be ampersand. And I mean, looking at this, there are clearly some very straightforward binary operations that I should be trying to think about a way to handle binary operations like without this degree of repetition, but whatever. That's a problem for another day. Oh, it just worked. They all just worked. This is the computer programming experience I deserve, is just for everything to just magically work. Amazing. Okay, let's keep this going. Or there we go. That's bitwise or. Come on. Yes. Love it. So these are ors. And I think it was complaining about XOR. Is that this? What is it in Ruby? So if I set a 1 there, I should expect it to turn this one off. Sure, that's fine. X. Oh, so cool. Oh, I love it when things just work. It's so rare that we get that experience as programmers, that things just work. That's very nice. Okay, so now it's complaining about shul. Like I said, I suspect that this is shift left. Return the result of shifting it left by k bits modulo 2 to the n. So the modulo 2 to the n part is essentially saying this is what mask is doing. So mask is making sure. This is saying if you shift all the bits a certain number of positions to the left, and you end up with more than n bits, then doing modulo 2 to the n means just chopping off the top, chopping off the overflow, basically, and that's what mask is doing. So I think we'll get that aspect of it for free. We just need to do the actual shifting. So it's... Oh, actually... Oh no, we get the modulo. I was going to say the distance shifted is also... Oh no, the distance shifted is modulo n. So if we said we wanted to shift it 35 bits, then that actually, if it's a 32-bit number, that means shift it 3 bits. So we don't get this part for free, but let's see. Let's just sort of theatrically ignore that for now and just do the shift left. The reason I was looking at this was just to understand which one is that. So I1 is the number that is shifted. So it's left that is shifted, and it is shifted left by whatever the value of right is. So I'm expecting this to pass some, but maybe not all, of the tests. Yeah, expected 1 got 0. Yes, this is exactly what I was talking about, or at least this is trying to shift left by 32, we need to interpret that as shifting left by 0. So I mean, the temptation is to just do this. Should I put parens around it to make that clearer? I mean, I assume that works. Yeah, that's fine. I'll take that. Yeah, I mean, I think that's fine. I'm just going to leave that like that. What's next? Shift right. Signed, I bet. Why are the signed ones always first? Just let me do the unsigned one, and then I'll move on to signed. So same deal, that kbi2 modulo n. So this is saying that the distance we're shifting by is modulo the number of bits there are. Return the result of shifting it right by k bits extended with the most significant bit of the original value. Wow. Okay. I mean, this is a little bit surprising to me because this is, well, this is the signed version of shift right. Because normal shifting right for an unsigned value just fills in with zeros. So as you shift, like when you shift left, you fill in with zeros. When you shift right, you fill in with zeros in the most significant bits rather than filling in zeros at the least significant bits. But this is saying extended with the most significant bit of the original value. I mean, I think what this is trying to say is that it's not saying this, but my interpretation of what this is saying is it's like, sorry, I'm not being very articulate. What I'm thinking is we can get this effect by interpreting the number as a signed number, and then in Ruby that's going to be represented as, if it's a negative number, okay, so if the most significant bit of this value is a 0, then this is equivalent to what we would be doing anyway, right? If the most significant bit is a 0, then we're going to fill it in at the left with zeros, and that's what we do anyway, so it's fine if it's a positive number. But if this is supposed to represent a negative number, then the top bit's going to be a 1. And if we interpret that as a negative number in Ruby, like if I say -5 in Ruby, if I say show me that as a 32-bit number, like there are an infinite number of ones, you know, in this sort of arbitrary precision representation. It's like all of the high bits are ones, and then we've got, you know, 5 down here. That's like -5. So what I'm thinking is that if we take the signed interpretation of the number and then shift it, you know, like -5 shifted right 1 place, -3, you can see that it's sort of done that because we're shifting in from that infinite supply of ones in the high bits, like they're coming in from above. And then if we converted it back into an unsigned number, I think I'm not explaining this very well, but basically I'm semi-ignoring what this is saying and just instead thinking, well, if this is supposed to be... What's the instruction called? Shift right signed. I'm tempted to do this sort of thing. So not treating the right bit, not interpreting how many bits to move as signed, but treating the value that we're shifting. So yeah, okay, sorry, I'm sort of clamming up here because I'm thinking rather than talking. So I think if we take this signed left value and shift it right, and then we convert it back to unsigned, I think that's going to give us the right answer. That was a very poor explanation. Oh, yes, it's because I need to do this thing again. All right. Well, even though I explained that poorly, it works. So maybe just ignoring what the spec says. Basically, this is saying shift right signed is like evaluate this left expression and then interpret it as a signed number and then tell Ruby to shift that right using normal shifting right semantics and then just convert it back to an unsigned number. And that does, for a reason I haven't really very well articulated, that does the same thing as what the spec is saying here, which is not a coincidence. I mean, that's why this is called shift right signed. It's just sort of the reason this works is sort of obscured by the way it's defined, because this doesn't, unlike the division stuff we were looking at above, this doesn't use the signed and inverse of signed sort of interpretation functions to explain the semantics of shifting right, but it's because it's just sort of encoded the behavior in this kind of extending with the most significant bit business. I haven't even tried to read this. Not massively clear what this means. Anyway, apparently this is right because it works. What's the instruction called? Shift right S. Okay. And then it was shift right unsigned, I think. I think that's going to be more like this, actually. In fact, I'd be very surprised if it's anything other than this. I haven't even read it. Yeah, great. So these are unsigned. And then what was it? Rotate left. And there's no signedness here. So rotate left. I'm sure the spec will say this. Well, it says the result of rotating it left by k bits. So this is just talking about if we've got a binary number. Well, let's go with 00101010. If you were to rotate that left by 3 bits, that means that you shift the top 3 bits off the top and wrap them back round onto the right hand end. So we're looking for 01010, so the bottom 5 bits, and then 001. So the result, the 8-bit result of rotating left 42 should be 81. And the thing about that is we can treat this result as being 2 different things smushed together, right? One of them is the result of shifting this right by 5. The 001 is just what you get when you shift this 8-bit number right by 5, or I should more explicitly say 8 minus 3. And then this top pattern, 0101000, is what you get if you shift the original number left by 3. So this final result, 81, is what you get if you combine this with, so by doing bitwise ORing, this with this. So you got the thing that you shifted left. Oh, right. Yes, the problem is that this is now 9 bits. But the bottom 8 bits are correct. So I guess this whole thing has to be masked off with sorry, that should be and. There we go, 81. So we have to rotate left by 3. We have to shift it left by 3. I guess maybe I could have masked that one. And then combine it with shifting right by 8 minus 3. So what that looks like here is that I want to do, I mean, I'm definitely going to have to evaluate both of these. I'm gonna need both of these in local variables, aren't I? So the value that I'm rotating is this. The distance by which I'm rotating it is this. And then the result is, oh, I bet this is a situation where I don't need to worry about masking it, do I? Because that's the blanket. This is another situation where we're already doing that as a sort of a blanket convenience operation. So actually, I think I can avoid that. I think I can just say value shifted left by distance. So in that example, it was 3. To shift everything apart from the top 3 bits up into the right position. And then I can bitwise OR that with the result of shifting the value right by bits minus distance to get the rest of the bits, and the ones on the right will just fall off. And then I'll OR them together, and then it will get masked here. And then that should be the right result. It's not. I bet this is a modulo situation again. Yeah. It's being, yeah. don't know why this worked. Modulo n. So this is modulo bits. Amazing. What is it? Rotate left. Okay, rotate right. I think that that's just going to be the opposite. Because, and what I mean by that is that the value is being shifted right by distance. And to fill in the gap that's left in the high bits, we need to shift it left by bits minus distance. Oh, so good. It's so good when things work. Okay. So rotate right. Again, I'm sure that there are hardware instructions for all of these that we could have been using, but Ruby does not expose them, so we just got to keep churning through. All right, CLZ. So I said before, I think that's probably count leading zero. So it's like how many of the high bits are set to 0. Yeah, returns the count of leading 0 bits. All bits are considering leading zeros if I is 0. So this only takes one argument. What do I call that? No, I've just called it value, which is a little bit of a cop-out. But have I got a better name than that? Not really. I mean, the very first thing I need to do is evaluate it like this. It's a little bit naughty, but whatever. Let's just see if I can get it working. So I think what I have to do is I think I'm just going to do a sort of pretty gross iterative implementation of this, which is to say have some kind of count initialized to 0 and then like count all the bits and then return count here. I think that's how it's going to be. Because I can't think of a nice way without writing a recursive function to do it. I can't think of a nice way to do this without just having a loop and then breaking out of it. But I suppose that's fine. This is just Ruby. So the reason I'm hesitating is I'm just trying to think about whether there's a nice sort of arithmetic way of doing this. But I think I'm just going to do it in the obvious way. The obvious way being, if I want to know if my value is, if I want to know whether the nth bit is set there, so if I want to know if, assuming these are 0 indexed, if I want to know whether 0, 1, 2, 3, if the 3th bit is set there, then I have to say value or 1 shifted left 3. And when I say or, I mean and. Yes. Whereas the tooth bit is not set, and so I'll get a 0 when I do that. So this is just taking a 1 and shifting it into the right position and then doing an and to check to see whether there was also a 1 in that position, and you get either 0 or a non-zero result. So I can just test every bit in like that. So I just need to start at 7 and then do check 7, check 6, check 5, check 4, increment that counter each time. Until I really want to find a nicer way of doing it, but I'm just going to try and power through and do the gross way of doing it. So the gross way of doing it is like bits minus 1 down to 0. Does down to take a block? Yeah, it does. So you can see this is what it does. 10 down to 5 with a block is just going to evaluate the block once with the argument 10, and then 9, and then 8, and then so on. This is a little bit horrible, isn't it? Oh well, whatever. So basically what this is going to do is increment the count, but what we want to do is say like break if value and 1 in that position is non-zero. And it could be unless 0, but I think maybe writing it in the positive sense like this is, we're going to stop if we found a non-zero bit. I think that's maybe a little bit clearer than doing unless. Does that give the right answer? Yeah. I mean, I don't feel good about it, but who's got time to feel good about themselves in this economy? Clear count leading zeros. All right, what's next? I'm just going to keep going with these because I think I can. If I would really like, this is quite dull. I'd quite like to get this done, and then I don't have to look at it anymore. Count trailing zeros. Well, I suppose this is the benefit, is that now I can just change this to say 0 up to bits minus 1. So it's sort of exactly the same code because I assume this is the kind of trailing bits. So now we're doing exactly the same thing, but we're just iterating over the bits in the opposite order. That's fine. My standards are very low at this time. What time is it? Just gone 11. I think I can get this done. Next, population count. So this is very similar again, but now, well, so this is sort of interesting. So I should say population count counts how many bits are set. Return the count of non-zero bits in I. So rather than counting leading or trailing zeros, it's asking how many of the bits are set to 1. And we've already got all the machinery we need to do that. We just need to slightly refactor this so that the count is only, instead of instead of breaking, we have to iterate over all of the bits. But we only increment the counter if we found a non-zero bit. So that's all fine. The reason I sort of hesitated is that this is one where where there's a cleaner implementation of it, because you can just use enumerable count. But then does that obscure? Well, let me commit it first. I don't know if I care about this, but instead of doing this thing where you initialize the count and then you mutate it, you could just do, well, and also the sort of off by oneness of this is a bit grim, but if I do sort of either 0 up to bits exclusive, this triple dot is like an exclusive range, I could do map, or actually I could just do bits times count, position, value, and 1 position non-zero. So that's like a more compact way of writing the same code. But I fear that sort of obscures the relationship with count leading and trailing zeros. So even though if I was writing population count on its own, I think I would definitely write it like this, but I think I'm going to leave it like this so that it's more similar to the other ones. Again, trying to prioritize clarity over cleverness here. Yeah, I think that's all right. Okay, extend 8s. What does that do? Return. So I think this is extend m underscore s. So remember, this is, I think, I32. Yeah, because we're in I32. Yeah, I32 extend 8s. So what does it look like? Extend 8s of 0 should be 0. Extend 8s of 7f should be 127, which is 7f. Extend 8s of 128 should be minus 128. Extend 8s of ff should be minus 1. It's 255. So is this something to do with 8-bit signed numbers? Because minus 128. Yeah, okay. So just looking at this, just trying to get a feel for what it looks like this means. It looks like it's saying, like, look, here's an 8-bit signed number, and I want to interpret it as a 32-bit unsigned number. So I think that's what extend means. It's like extend this 8-bit signed number to be a 32-bit signed number. I think that's what that means. So I realize I haven't even clicked on the thing in the spec here, but I'm sort of enjoying thinking about it in these terms because it feels like we've already got all the building blocks that we need to do this, because we can interpret this as signed, but 8-bit, not 32-bit, because we've got the helper that knows how to do that. Like, So if we do this, I can get the, I wanted to say signed value. Is that what I did elsewhere? Yeah. So signed, the signed interpretation of that value is signed value, but the bits is not 32, which is what bits is, it's 8. So interpret that as an 8-bit signed number, and then the result is the unsigned interpretation of that signed value, but in the correct, the 32-bit unsigned representation of whatever signed number we got out there. So to me, it feels like this is just something that we've already got all the Lego pieces for this. This is just an interpretation function, and we've already got all the machinery to do the interpretation. It was just plugging in this 8 here, round tripping it through the signed and its inverse. Not quite, because one of them is like signed sub 8 and the other one is inverse signed sub 32, because it's like a different interpretation, a different width. I mean, I'm again quite smugly explaining all that without knowing whether that's right, so let's find out whether it's right. It's not, is it? I mean, for the ones I was looking at, it's right. So for these, but not for this. Extend 8s. Yeah, so this was all. I think I've got the right idea. But this is not working. I mean, this is clearly not an 8-bit number. Oh, and it's even been written in such a way as to the underscore there is separating the 8-bit, the bottom 8 bits from the rest of it. And so this is suggestive of the fact that this top bit here needs to be thrown away. And we're not doing anything about that. Right. So I guess the problem is that even though this evaluate is masking off the result that we get, or it would be if it was, it's only for the arithmetic operations. Oh no, it's true for const as well, right? Yeah. So it does get masked off, but it gets masked off as a 32-bit value. I mean, should signed and unsigned be a bit more? Maybe signed and unsigned. I'm trying to. Well, I've got to do I've got to mask somewhere. I've either got to mask this value. I've got to. I think I could make the test pass by just doing this. That's the problem, is because this value is not being masked off to its 8 bits. Yeah, that works. But the reason I was hesitating is because I was thinking, like, maybe in these functions where you say, I want the signed interpretation of this thing, assuming an 8-bit number, like, maybe the strictly correct thing for it to do is to mask that number off before it tries to work with it. Because obviously, if this number is, the reason I'm saying obviously is because both of these interpretation functions are the identity function for half of their intended input range. Well, the reason I'm pausing there is that for this one, it has to actually be a small number, so you wouldn't get that problem. But for this one, you could have passed in an arbitrary size number, and as long as it's not negative, it will just pass through this function completely unchanged. So I think that now that this problem has revealed itself, I think the right way to fix this is to say unsigned is mask unsigned bits. signed equals mask signed bit. So like, if you're going to try to interpret me, then the very first thing that I'm going to do is chop you down to the number of bits you're asking me to interpret you as, because if you've got any more bits than that, I'm not interested. So I think that achieves the same result here, yes, and is a bit more correct. So I'm going to say mask values inside signed and unsigned to the right bit width. These methods pass some of their inputs through unchanged. But so to ensure they're the right width, we need to cut them down in case they have more bits than we were expecting. This is necessary for the implementation of I32 extend 16s and I64 extend, oh sorry, it's 8. Yes, and now we can just say, I think that's nice because it makes this implementation way simpler. The reason I've stopped there is that I think maybe, do I want to inline some of this? Is this clearer? I think maybe it is a little bit, because that makes it separates out the evaluation of that thing, but then I think this makes it clear that you're not really doing anything apart from just round tripping this through the signed interpretation function and giving it a different number of bits. So I think I'm going to write it like that. I mean, I'm assuming that I've realized that all the way through I've been saying we've been implementing the i64 variants, and we haven't actually run any of those yet. Oh, and of course we're not going to, because none of them are in here. So maybe this is a bit of a, oh yeah, it wasn't really the right thing for me to be doing, was it? Because I don't know. I mean, I assume that I'm implementing those, but I actually don't know, because I'm not testing that at all. See, it was because I was in literals did have me working with 64-bit numbers, but I think this was the point at which I came unstuck. Was that I just got overexcited. If only I'd realized this sooner, I could have saved myself a lot of typing, couldn't I? Sorry. This is even more tedious than what I was doing previously. Nearly there. Dangerously close to being done now. Okay. All right. Well, sorry about that. We regret the error. Okay. So where am I? Extend 16s. Well, this is one of these times where there's a temptation to do that thing again. I think I'm going to do it. To make this a regular expression and say I'm matching extend this is either a or 16 and then this is a number of bits. And then let's say extend bits is match bits to I, and that's this. Sorry, extend bits. Yeah. So now I'm just getting a and 16 here, and then just pulling out that number. Is that a bit gross? Maybe. Hasn't saved me very much. Oh well. I've done it now. I don't really know why. That wasn't, strictly speaking, necessary. Because there's only two of them. But whatever. Okay. What's EQZ? I assume this is comparison with 0. Return 1 if I is 0. 0 otherwise. Okay, so Boolean interpretation. The integer result of predicates is defined with the help of the following auxiliary function depending on the result of 1 or 0 depending on the condition. So this is a thing that there's no Boolean type, like we only have integers, and so we, instead of having true or false in the result, which we've got no way to represent, we just return 1 or 0. So return 1 if I is 0. Okay, so this is I, EQZ, not I, value equals evaluate value locals, well, if value is 0, then 1 else 0. Sure, that works. Oh, I forgot to done a commit for this thing. Oh, this is a mess. This is a mess. This diff is a mess. Let's just undo that. So this is just implementing 16. There we go. It's because of this, because this value line was repeating, it had made the diff algorithm get confused. So that seems fine. I don't love it, but it's fine. Am I gonna want to implement that bool? Yeah, let's just do it. I know that I'm gonna want it. So this is just going to use the, what was, this said it uses the, yeah, this is sort of using the truthiness in the sort of mathematical world, the truthiness of some predicate. So I can use Ruby truthiness here to represent that. So I can say, so here I can just say bool value is 0. I can see that there's a bunch of these coming up, and so I'm just going to do it now. Yeah, okay. There's really nothing interesting to say there. Yep. Okay. The other one is, the next one is EQ, which I assume is just equality testing. Let's test that assumption. Let me just pull one of these binary ones. Oh, see, they did them in line. Maybe that's what I should have done here. Yeah. Okay. So let's look at something like add. It's going to be my template here. Is it just EQ? Is that what it was called? Yeah. Okay. So left and right are equal. I'm going to test them for equality, and then I'm going to wrap this whole thing in the bool helper to turn that into 0 or 1. All right. I'm sick of that again. So that's EQ. The next one I think was NEQ, which is just this. NE. Yes. Get the name of it right. And now we need LTS, which sounds very much like less than signed. And just to save time, I'm going to wing it and see what happens. So it's going to be a less than, but I'm assuming that we need to take the signed interpretation of both arguments. Missing keyword bits. Oh yeah, sorry. I mean, this is getting a bit gross. But who cares, because it works. All right, I know this is just a grind, isn't it? But I assume that there was going to be some amount of this. It's all right, we'll get there. So this is unsigned, so we don't need any of this nonsense. Less than unsigned. Yep, great. Again, I'm sure there's a way, and I will probably think of it tomorrow, because my brain's basically running on empty at this point. I'm just plowing through these incredibly boring operations. There must be a way to make this less repetitive, but right now I just want to get to the end of this file and make them all work before I even think about like how could this be more clever. And I think I'll let myself think of something clever, not right now. So this less than or equal to signed. So we just replace that with an E, and this just becomes an equal sign. Yep. And now we want LEU. So this is literally just this. But instead of T, it's E. And then we put an equal sign there. Yep. Of course, if I'd come up with a nice little framework for implementing all of these, where I just had some kind of lookup table that said what the name of the Ruby operation was, and I could use a regular expression to detect whether it was signed or unsigned, I could have automated all of this. And now I'd just be gleefully filling in entries in a table and seeing all of these instructions work. But instead, I'm doing it this way around. But of course, if you make an abstraction like that ahead of time, you never really know whether it's going to do all the things that you want it to do. So I think that's why I'm, patiently grinding through all of this manually, is because I don't want to assume that some clever thing that I come up with is definitely going to work. I'd rather just, do the simple thing, and then I can come up with something clever later once I've got enough evidence to substantiate the fact that it's likely to work. Okay, greater than S. Let's take a signed one. So GTS. I think that is probably this. I am correct. I wonder why all the signed ones are first. It's very strange, but whatever. And now greater than unsigned. So again, basically this. Yep. GES. This is really just the sort of Cartesian product of all of the different aspects of this, right? This is greater than or equal to. Good. Now we want GEU, basically the same as this. It's slightly losing the will to live now. Well, at least something interesting has happened. I think this is another assertion that we don't know how to deal with. Assert invalid. Where's that? Oh my god, have we made it through all the assert returns? Is that what this means? Yes, it is. So these are assertions about type mismatches. I mean, there's an awful lot of them, so this does look quite important. But I'm just not even going to try to find any type errors right now. I'm sorry. That's not what I'm doing. So what did I say about this before? Ignore the assert trap command. Yeah, what did I say about this? Yeah, okay. So let's do the same thing here. Yeah, I mean, essentially, I just want to say this. So I'll say, as with assert trap earlier, I haven't thought about how to check types yet. Yes, I got it done. Oh, that was very boring. When did you say, fuck, when did you say that? Count trailing zero and population count as well. When did you say that? Oh dear. Okay. About 5 minutes ago. Okay. What was that relating to? Sorry, is there something I've forgotten to do? I'm relying on you to be my brain now because mine has dribbled out of my ears at this stage. I wonder what you could have been talking about. Maybe you were talking about masking? Oh. You were talking about silly zush. Right. I forgot about this. I forgot you can slice bits out of an integer. Oh, okay. All right. I'm going to do this. I'm going to do this as a celebratory. Thank you. This is excellent. This is exactly, so it is equivalent to, oh, right. Yeah, of course. This is another way of doing it. I didn't think about this. Instead of shifting one up and anding it, you can shift the value down and then and it with one. Interesting. All right. Let's see if I can. I don't think I have ever used that. Does this have an alias? Can you use slice? It doesn't say that you can. So this is saying that. So is this 1 indexed or? Yeah, 0 indexed. Okay. So no. Okay. It's a shame that it doesn't have a nice name. But nonetheless. So basically what that means is that instead of this value and 1, so hold on, this returns, right, so I can't just use the truthiness of this. I have to use this is sort of interesting, isn't it? All right, firstly, I'm excited that I've got this file working, but secondly, I'm excited that I might be able to clean up this slightly gross code. So this thing is equivalent to value position, I think. Let's take it nice and slow. Yes. So these are all, and this one. So I think, I mean, YouTube must have just dropped one of the things you typed to Fook, because I think that your first message must have got lost in the pipes or something, because I didn't see it. But I think probably what you said was that it could be used for CLZ, and then your subsequent message said CTZ and pop count as well. So it feels like those are the three places where it's relevant. I mean, that's much nicer already. Oh, okay. Yeah, you had a link to the docs in your first message. It didn't show up at all. So I don't know what's happened to. Oh yeah, maybe they don't like you posting links into chat. I don't know. Amazing. So let's say use integer square brackets instead of to check whether bits are set. So let's find the docs for that. Docs Ruby Lang org 3.1 integer square brackets. I mean, this is some, this is some deep shit afoot. Okay. So I'm going to link to this. So let's say rather than doing the shifting ourselves, we can use integer shifting and anding. I don't know why I've written that in bitwise anding. How do you spell bitwise anding? I don't know. Rather than doing the shifting and bitwise anding ourselves, we can use integer to pick out the bit we're interested in, and then we just have to test it to see whether it's 0, whether it's non-zero. Well, whether it's 0. That's the same thing, isn't it? Amazing. Thank you, Paracycle. I think that's your username, isn't it? Yes. Amazing. Thanks a fuck. I knew that doing this as a stream would eventually pay off. If I kept going for long enough, something useful would happen, and that single bit of obscure Ruby trivia has vindicated this entire pointless project. Now, the only thing that this makes me think, and perhaps this is dangerous, is that this gives me a nicer way to do the thing I want to do. Like, if I want to know how many trailing zeros there are in 248, what I can do is say it's not worth it, is it? There's a real temptation to just do some sort of code golfing here. I can feel the lure of cleverness, because what I'm thinking is that because this because this thing can take a range or an offset and a size, I can just say, give me 1 bit at position 0, give me 2 bits, give me 3 bits, give me 4 bits. Oh, whoops. I should have, the answer was 3. So there's a temptation to say, like, 8 times max by is this right? N 248 0 N 0. What? Do I not understand what max by, how max by works? Oh yes, I am misunderstanding how max by works. What I mean is, can I use max for this? Oh, that's got to be the comparator. Okay, never mind. What's the nice way of doing this? I mean, this doesn't matter, does it? Like, this is just pure. You've just nerd sniped me now. Oh, take until, right? Yeah, that's actually exactly what I want. Good old. Well, does take until exist? Why didn't RI find it? Has it been taken out? Yeah, take a while. Calls the block with successive elements as long as the block returns a truthy value. Returns an array of all elements up to that point. Right, okay, fine. That's just you losing your mind. So it would be something like 8 times take while 0 last. Oh, that's so silly. That's so silly. So what about what about the other? I mean, I think I'm not going to put this in. Like, it's very satisfying that this works. Let me write this. So this is 0B 1 1 1 1 2 3 4 5. Then we get 5. To do it the other way around. So this is the situation where range is quite good, isn't it? Although maybe this, can this be negative? No, apparently not. How does that work if that's negative, though? Well, obviously it doesn't do the thing that I was hoping it would do. So it needs to be, if we're doing the top 1 bit, then this needs to be 1. Yeah. Well, but it's in the other direction. So it's not 8 and 8 minus n. It has to go down. This has to be 8 minus n, right? And this has to be n. No, because this is going to be 0. So this is... Oh, God. Yeah, so this is... because this is, oh no, what a disaster. This has all gone wrong. The offset will always start from 8. But why? It counts in the opposite direction, doesn't it? Or are you saying it doesn't? Oh, it doesn't. No, hold on, it does. Hold on. What's even going on here? How does this even work? So this returned 5, 0. So size here returns size bits from self, including bits of greater significance. So it always goes up. But now I'm confused about how this works, because when n is 0, how does this work? How does slicing 0 bits out of this even work? I'm very confused now. And actually, I think that this isn't right, because this should return 8 and it only returns 7. Oh yeah, I think find was what my brain was reaching for, although we want the last one, not the first one. So there are several problems with this. One, the problem is that I missed the off by 1 error here. So this needs to be, yeah, I mean this whole thing is a shit show. This needs to be 1 through 8, not 0 through 7. So me using times here was not wise. So that does the right thing. That does the right thing. So there was an off by 1 problem. And how would it work the other way around? How do we get the 4? So now that I don't have an off by 1 problem, I think it's correct that this can be 8 minus n and that can be n. I think that was the thing that was preventing it from working before, was that because this n was off by 1, firstly, all of this was wrong, and secondly, the actual value that you got out the end was wrong. So you can do count leading and count trailing zeros in a nice little compact one-liner like that, a little bit like the compact one-liner that I did for pop count. So I could rewrite all of these. I could rewrite all of these to use. I could rewrite all of these to just be a sweet little one-liner. Pop count is the size. What do you mean? I don't understand, I'm sorry. Right. Yeah, I mean, pop count is... Oh, right, I understand what you mean. You mean this. Something. Yeah, I think you weren't here when I was writing pop count, but I actually did. I rewrote pop count as a little one-liner that was actually just using count, which I think is even better than taking than doing anything else. But I'm going to think about this, because it is very cute that this is possible, and this is very cute. But I'm worried that this is the whole reason why I start with the reminder of what my principles are, because it's to prevent myself from writing code that's too clever. So I think I'm gonna stop now. This is super cool. I'm really glad to have got rid of the shift in there. I think that's really nice. I'm gonna ruminate on the idea of because all of these can be rewritten to be functional now, right? They don't need this none of these. This one never needed it, but now the other two don't need that mutation, because we can just use something like this. But I'm gonna sleep on that one. So to celebrate, I suppose I'm gonna add i32.wast to this, because I think I should be able to like add i32.wast to GitHub CI tests. I'll just put CI test. Don't need to give Microsoft any more free advertising on my commit history. Okay, so this is going to be the treat at the end of this painful experience of implementing all of those instructions. Push. Come on, Azure. As soon as you're ready. Amazing. Well, that made those 4 hours of laboriously implementing all of those integer instructions completely worthwhile. Great. Okay. I can't be bothered to write all this down. Let's add this to me notes as a thing to think about. Can I just paste this in? Yeah. Okay. So that's something for me to think about. All right. Well, blimey. Golly gosh. Wasn't that something? All right. Well, yeah, just coming up on the 4 hour mark. Thank you for watching this. I promise I didn't realize it was going to be that tedious and that lengthy, but it feels great to have done that. It's working. I can go to bed safe in the knowledge that I'm done with those 32-bit operations. Next time, we will check that it also works for all of the 64-bit operations. I promise not to check that until I'm on the next stream, so you can see me live discovering whether I'm done with those integer operations or not. But yeah, I mean, that's it. That's all that's going to happen. Thank you so much for watching and joining me on this weird, tedious journey. Have a good evening. I'll see you next time.